Hi guys. So week 5, we're still at home, and this is going to be lesson number 1 for week number 5, and we're going to go back to the one note again, and we're just going to finish off this atomic theory and just add an extra couple of bits this week, and then we're into midterm break next week, and hopefully that's the end of that. But this is really the last topic I need to do some theory with you on, so we're straight into practical work when we get back to the lab. Okay, let's go back to the one notes. All right, pad down so I can write on it. So this is just from last week. Here's all our stuff from last week. We had questions and we drew out loads of these atoms over here. So we drew out, remember, if we wanted to draw out calcium, we had 2 electrons on the outer. We 20 in total. We 2 on the first shell, and then we'd 8 on the second shell. And then we'd 8 on the third shell, and then we'd 2. So we used up all 20 and we put the electronic configuration in there as 2882. When it came to something simple like helium, we drew out just the 2 electrons in helium because helium only has 2. So the electronic configuration was 2. Just keep that in the back of your mind as we go forward. And also, I want you to keep in the back of your mind these definitions as well. The atomic number, which is important, and the mass number. So if we go look at any element like nitrogen, our atomic number is here, and our mass number is 14, which is number 7, which is the bigger number. So the atomic number, do you remember, tells us the amount of electrons and the amount of protons. The mass number tells us the amount of protons plus neutrons. So just keep that in the back of your mind. And we're over here in the left-hand column here. I've put in a new one for this week, Friday 8th to 12th. So this is the extra thing I want to do, keeping the stuff from last week in mind. Don't forget them, okay? So here we go. We're sticking with this idea of the periodic table, okay? And I've put in a new periodic table for you there, okay? And the title is periodic table up the top. So I want you to have a look over this side at what the different things are. You might have to have a look at these yourself, nice and slowly. So the alkali metals are the blue, a dark blue. Lighter blue are the alkaline earth metals. Over here we have the halogens and the noble gases. So these are the ones that I want you to remember. I want you to remember these ones, these ones, these ones, and these ones. And on the periodic table, where those are, so here's the alkali metals are here. So these ones here are, let me see how I'm going to do this. Those are those ones. They're color-coded as well. These ones here are the second one. These ones here is this group here, and the noble gases are that group there. So we only have to worry about 4 different groups for junior cert. We only have to worry about, and they're numbered. This is group 1, this is group 2, this is group 7, and this is group 8 at the end. So there are 4 different groups. So the way the groups are, you have group 1, group 2, group 3, 4, 5, 6, 7 and 8. All these ones in the middle here are a bit of a mess they don't really obey any of the rules that we're going to look at. So we're going to worry about 1, 2, 7 and 8. They're the ones I've highlighted for you. I'm just going to get rid of that highlighter because you won't be able to see the colours. So there's your 4 groups that we want to see. And we'll see why in a minute. So what we want to know, in a periodic table, what's a period? So we call it periodic. So what's a period? And what's a group? And what's the periodic law? Write the electronic configuration of the first 20 elements. Well, we've already done that, haven't we? Last week. We did about 5 or 6 of them, and they're all done the same. Excuse me. This we haven't done. State the characteristics. We're going to get to that in a few minutes. Identify the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Now, it just so happens, before we start, I'm just going to back up and have a look at that for a second, right? And have a look at the ones I asked you to highlight. The alkali metals, the alkaline earth metals, the halogens, and the noble gases. And you'll see there that these ones here are your alkali metals. These ones here are your alkaline earth metals. These, so question 7 are your halogens, and 8 are your noble gases. So we've kind of done that already, but we'll get to that in a second. Describe this thing, the octet rule. What's the octet rule? and recognize this guy, the father of the periodic table, father of chemistry really, Dmitry Mendeleev. He's a Russian scientist. Right, so we're going to work through those now. So we've kind of done that one as well already, even before we started. So after all, we kind of come up with all these elements. They're placed in the periodic table. Now this is important, and highlight this, is elements are arranged in order of increasing atomic number. Let's go back to our periodic table for a second, have a look. Well, they are, aren't they? Because if we start, we started lithium even. Here's atomic number lithium is 3, beryllium 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So they're arranged in order of increasing atomic number, so the amount of protons they have. They're also placed into things called groups based on their properties. So how they react with water, how they react with air, what colour they change when you put them in acid, all different characteristics. And these repeat themselves. So basically what I'm saying to you there is that if we were to take the first group, if I was to take, I'm going to just put a circle around the first group. If I was to take this group here, and these are called, remember, if I go over to see what are they called, they're called the alkali metals. So all of these ones, all them in this group are called the alkali metals. So that means that lithium is very similar to sodium, is very similar to potassium, is very similar to rubidium, is very similar to cesium, and is very similar to francium. So the ones in group 1 have similar characteristics. They behave the same. Okay, that's one thing. So here's the law. You just got to learn this, sadly, the periodic law. Elements are arranged by increasing atomic number with similar chemical properties. So increasing atomic number with similar chemical properties. So that's one thing. We know they go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that all the ones in the same group have similar chemical properties. This guy Mendeleev, he is responsible for creating the periodic table. So if a question asks, who is responsible for creating the periodic table? Your answer is going to be Mendeleev, Dmitry Mendeleev, who is a Russian scientist. And he came up with the periodic table. Okay, the periods are horizontal and the groups are vertical. Remember, vertical, if you were to think of which one's vertical and which one's horizontal again, here's a way to do it. Horizontal is the floor and vertical is the wall, like that. So if they're going straight across like that, it's going to be periods. If they're going down like this, it's going to be groups. Another way of putting the periods or rows go across like that. Groups or columns, like so. Now, the difference is that groups have similar properties but different number of orbits. So if we take groups to start with, they have similar properties but different number of orbits. Okay, and we get to that. Let's go back up and have a quick look at that for a second. So if I'm to pick something like this, if we to pick this group here, and I have number 1, lithium, and number 2, sodium, and I was to say, right, if I was to draw those, I'm going to put this all together in one nutshell for you, right, over here on the right-hand side. So if I was to draw lithium, I'm not going to do it out like I did last day. So lithium is, it looks like Li, and it goes 3 and 7, like that. So that's what it looks like in the periodic table. If I'm to draw that now, Li is 3. There's my nucleus. I'm going to put my electrons in like so. Okay, so I'm going to put this together in 1, 2, and 3. So there's lithium. 3 electrons. Doesn't really mean anything. That's just what it looks like. Electronic configuration is going to be 2, 1 if you wanted to put that in. Let me just quickly draw sodium beside it. So this is in the same group. And sodium is number 11 and 23. Sodium is like that. I want to draw sodium nice and quick. Na, which is going to be 11. There's my nucleus. And I'm going to need 3 rings this time, I think. Like that. I'm going to put my electrons in to sodium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I put my 1, 2, 3, 4, 5. I did. What am I doing? I had to put one too many electrons. I put 9 in the one ring, which we know we cannot do. We can only hold a maximum of 8. So I'm going to put an extra one in, which I cannot do because there's no space. So there's my element of sodium done. Now I'm looking at these two and I'm thinking, right, if I want to know what group these are in, so I can say, well, is the group, how many electrons in the outer ring? So how many electrons has lithium got in its outer ring? It has 1, doesn't it? How many electrons has sodium got in its outer ring? It has 1. So they both have 1 electron in their outer ring. So they're both going to be in group 1. Let's go back and see, are lithium and sodium in group 1? They are, aren't they? So what that's telling us is that group 1, all of these ones in group 1 have 1 electron in their outer shell. And you're wondering, what about the periods then? Because remember, the periods go across this way. So these are going to be your... Okay, like so. These are my groups. So from this, we can say they've 1 electron in their outer shell. So that tells me lithium and sodium are group 1. Lithium and sodium are group 1 because they have 1 electron in their outer shell. What about the period thing then? Because they're in different periods. If we go along here and we have a look, this here is going to be period 1. This is going to be period 2. This is going to be period 3. This is, I can't fit because of the word group in. This is going to be period 5, period 6. I say, well, which period? Lithium appears to be in period 2, and sodium appears to be in period 3. Well, where would that show on our diagrams? If lithium is period 2 and sodium is period 3, well then where does that show on the atomic drawing? And the reason it shows there is because the periods tell us how many rings it has. So if we look at here, here's 1 ring on lithium, here's 1 ring, and here's the second ring. So that is telling us that lithium is in period 2, whereas sodium is in 1, 2, 3. So this whole thing, period 2, because 2 rings. Period 3, because 3 rings. Okay, so there we've just basically summed up the whole topic. Periods and groups in the periodic table. How many electrons it has in its own shell, in its outer shell, tells us what group it's in. How many rings it has tells us what period it's in. I can go back really quickly to last week's work. I'm going to pick one of the random ones that we did last week, right? So let me see, what have we got? Oh, chlorine. Here's chlorine, right? So if we just look at this, and can I tell where chlorine is in the periodic table by looking at its structure? Well, I'm wondering 2 things. What group is it in? And what period is it in? So if we go to chlorine and I say, right, how many electrons has it got in its outer shell? That's going to tell us what group it is. So there, okay, we have 1, 2, 3, 4, 5, 6, 7. So I would think chlorine is going to be in group number 7. How many rings has it got? Well, there's 1 ring, there's 2 rings, and there's 3 rings. So I would say that, if I was a guessing man, that chlorine is in group 7, period 3. Let's go look at our periodic table. Group 7, period 3, is chlorine there. Right, where's period 3? Right, period 3 is over here. So we're going to go all the way across to period 3. And group number 7, which is here. So we go down, and there's chlorine there in group 3, period 7. So 2 things we're interested in. How many electrons has it got in its outer shell? That's the group. How many rings has it got? That's going to be the period. Okay. Does that give us anything in this? Nearly. Yeah. So we've done this one as well. Okay. Let's go down and have another look at where we are, right? So all atoms contain orbits. Some have more than others, depending which period they're in. So that's what we're saying there. Depends on what period they're in, how many orbits or shells they have. Electrons include that. We did this last week. 2 electrons in the first ring, 8 in the second ring, 8 in the third ring, and there are 16 in the fourth one, but we don't need to know that. I'm going to cross that out because we never go past element number 20. So as far as we're concerned, it has 8 electrons in its outer shell. We don't stick with 8. This one I want to show you nice and quickly. The octet rule. This is the governing rule of reactivity. So octet. Think of the word what? Oct. Oct in Irish or French. Oct means 8. So all atoms want to be stable. That's what all atoms want. And in order to be stable, they need a full outer shell. A full outer shell. So they all want 8, except helium and lithium. They all want 8. So if they don't have a full outer shell, they'll react with other things. They'll try and react with other things. Group 8, the last ones, all have a full outer shell, and so they're unreactive. Okay, so let's have a quick look, one more look at the periodic table, and we call it a day. So group 1, the alkali metals, these here are very reactive. They're extremely reactive. And if we're in the lab, we'll be doing all sorts of experiments with these here. Lithium it fizzes in water. So you put it in the water, it'll fizz around. It has 1 electron. It wants to get rid of that 1 electron. Because it has 1 electron in its outer shell, it wants rid. Because if it gets rid of 1 electron, it'll have a full outer shell. If we go out to what we drew here, have a look at lithium there. Poor lithium has this electron here. If it can get rid of that, it'll have a full outer shell underneath, which it can use. Poor old sodium has 1 electron here as well. That's why it's in group 1. If it can get rid of that 1 electron, it has a full outer shell underneath that will make it stable. That's what the octet rule. It wants to make a full outer shell in order to become stable. Okay, so that's what the alkali metals. Sodium, so I said lithium just fizzes a bit. Sodium will go on fire. And if we put that into water, and I'll do this switch in the lab, you put a bit of sodium into water, it'll go around, it'll go on fire like a little sparkler, and will burn out, trying to get rid of that 1 electron. Potassium, which I also have some in the lab, this will be like a banger. So it will go around, a bit of colour, it'll try and jump out of the basin of water, it'll make a loud bang. It's dangerous enough, but it's not too bad. So they get worse as you go down. Rubidium, cesium and francium were legally not allowed to keep in the lab because they do the same thing as sodium, potassium. They're all metals. They're all alkali metals. Remember, group 1 are called alkali metals. Group 2 are the alkaline. I'll just write them in so you can see them in one space. The alkaline earth metals. So when we get down here, rubidium, cesium and francium, these are dangerous, nasty metals. That if you were to take a small bit, to say the size of your thumb, and put it into water, you could lose the school. You know, you end up with it would be like a bomb. So especially cesium and francium, they're very, very, very dangerous, and they get worse as you go down. Group 2 are not as bad. Because they have 2 electrons, they're not as unstable. So things like calcium. Calcium's still a dangerous enough metal. Same as strontium. But they're not as reactive as the alkaline. Group 1 are very dangerous stuff. The other group that's very dangerous, group 1 is the worst. And close second is these ones here. Chlorine, fluorine, bromium, iodine and aspartame. They're quite quite dangerous ones as well. And the reason being is because, remember we drew chlorine. Chlorine, because it's in group 7, it has 7 electrons in its outer shell. So it's going crazy to get that last electron. Group 8 are your noble gases. They all have full outer shells and they are very, very, very happy elements. Things like helium, neon, argon, krypton, xenon, very, very happy. They'll go into a light bulb and sit there for you. They'll, let you put them in a balloon and they won't react. They don't want to react because they have a full outer shell. So your 2 big reacting groups are group 7, your halogens. So halogens. And really unreactive one, because they have a full outer shell, are your noble gases. They do not react. So alkali metals are very reactive. Alkaline metals are just reactive, kind of reactive. Halogens are very reactive. And noble gases are not reactive. I'll just put in beside them why. So very reactive because 1 electron. These have 2 electrons. These have 7 electrons. And these have 8 electrons. So remember, they want 8. The octet rule means they want 8 full outer shell. If they get a full outer shell, they're happy. If they don't, they're very annoyed and they'll whiz around and cause all sorts of fire and explosions and colours and all in order to get that full outer shell. And these kind of ones that we'll be looking at when we go into the lab. We'll do experiments with all the alkaline metals and the alkaline earth metals, and we'll make a table of reactivity when you can see it for yourselves. But we'll stick with the theory for today. Okay. Now, what I want you guys to do for our next class is just these couple of questions based on atomic theory. There isn't too much of them. Either do them in your copy and take a picture, upload to your homework section, or copy the whole lot into your homework section and write the answers in on the worksheet, right? So there's a couple of questions on the periodic table. Identify the groups, so the names, these are already alkaline metals, alkaline earth metals, halogens, and noble gases. What do they all have in common? Well, what do all elements in group 1 have in common? We did that with sodium and lithium. Same with group 2, same with group 6. Bit about the octet rule, and what can group 7 ones do? What can chlorine do in order to become stable? Well, it has 7, so what's it going to do? So quite a handy little exercise. Any questions in the meantime, you can ask me, and our second class of the week, of course, is live as it is every week, and we'll have a bit of time to chat through this. And but as I said, in the meantime, send me an email and I will give you a dig out, because like I said before, this atomic theory periodic table thing can be tricky until you get to understand it. All right, have a great week, everyone. Talk to you later.